Thank you very much for having me here. And my name is Valeri Souchkov, and I'm coming to you from, if you can see here, from the Netherlands, but actually not exactly from the Netherlands. 3 o'clock in the morning, I woke up and went from Pune. You know, this Pune, it's an Indian city, not far from Mumbai. Because I was there for the reason which is directly related to my today's presentation. So I'm going to talk about TRIZ. So I know that perhaps 99% of you are people from digital world, right? Agile people, software people, and so on. Actually, I also started in a digital world. I was graduated as a computer science engineer, and I was one of the co-founders of the company which was called Invention Machine Corporation, right? And yes, at that time we used artificial intelligence techniques. I used to code in Prolog language. I don't know how many people know the Prolog language today. I see that not many, but it was really popular somewhere in the beginning, in the end of 80s, beginning of 90s. So, but what did I do? Actually, today I'm not talking much about software. I'm coming at a rather higher level. I'm going to talk to you about something really, really unique. Something that, well, brings us to the next level, both in product development and innovation. I was doing a lot of work in artificial intelligence. I was working with ontologies, etc. But somewhere in 1995, I realized that we have no artificial intelligence. All what we have are good techniques, but we just have no enough capacity to run these techniques. It was 1995. And if we want to have a real artificial intelligence, that should be that machines start awareing of themselves. That would be a true artificial intelligence. It's my opinion. Unless they are not aware themselves, we will never have artificial intelligence. And software, we can code everything as long as we have a theory. Yeah, if we have a theory, we understand it, we can translate it to code, and it will work. But our intelligence, our mind, is something we don't understand. We don't understand how it works, so we cannot transfer it to a code. Simple as this. So I decided to make a little step ahead and move from the computers. I say ahead. Many people thought it would be a step back, moving from digital world into the, well, material world. But to me, it was a step ahead because this was about bringing our thinking to a radically new level. And all this time, all the 30 years, I worked with TRIZ. And today, I'm going to tell you a few words about TRIZ. At least you will know what it is. And also, how it can be combined, well, we are just starting it, of course, with Agile. And what's common between TRIZ and Agile. So, my talk will be about 3 points. So, well, what's the problem? Why I'm here? Second, what is TRIZ and how it helps? And third, well, actually, how Agile can be enhanced with TRIZ. Or maybe TRIZ can be enhanced with Agile. But we will see. So, well, if you look, I'm not an Agile specialist, first of all. Also, my first keynote about TRIZ and Agile was back in 2012, almost 6 years ago. This time has not been many changes since that time. Also, I try to understand Agile methodology. I try to understand how it works. I try to understand the tools which are used to implement Agile methodology like Scrum, Kanban, etc. I've seen a number of projects with Agile. But again, my task, I'm more working with real inventors of the material world. So that's actually what I've seen recently, published about idea of the stage gate process of innovative development with Agile for high-risk projects and for development of new products. So where in the stage we get the biggest problems we have definitely at the beginning. What we call in innovation innovation front end, when you need to create an idea of a new product, or let's say a new service, whatever you innovate. And my experience of being 30 years with innovation, well, actually, my customer base is approximately 400 customer companies now, which I consulted and I trained in TRIZ. So that's rather big, and I'm talking companies like Samsung, companies like LG Electronics, companies like Mitsubishi Electric, and so forth. Well, since I'm in Holland, from the Netherlands, there was something at Philips as well. But Philips today also starts running public TRIZ courses. That's a good progress. So, the problem with these first stages is a high degree of uncertainty. How to produce new ideas? How to produce winning new ideas, not just ideas? Well, creativity is a very simple way. When people tell me, oh, creativity is difficult, no. Creativity is very simple. If you want to create a new product, close your eyes, put your hands out, touch two objects on your table, bring them together, and glue them, and create a hybrid. Well, it will be creativity. Yeah, you will get something radically new. And what's most interesting, you can even patent it. So you don't need to have special skills to be creative. But the problem is that if you want to create something on demand to obtain the result desired, that's where the problem is. And I will show you today what's a major obstacle of obtaining great ideas. So, the key issues. Development of innovative products often faces the necessity to solve innovative problems. You know, actually, development of products, because I'm going to this issue of product development because Agile, first of all, has been developed for product development. And so far, Agile has been used in software industry primarily. But, like, what triggered me recently, 1 month ago, I had a talk, 4-hour discussion with one of the top managers, a science division manager from a company, 3M. Perhaps you know company 3M, which develops Scotch tape. And I personally consider 3M as one of the most innovative companies in the world, because these guys are able to create 50,000 different products, and the portfolio of their products, 75% of their new products, exchanges or updates every 4 years. So each 5th year, 75% of their products are new. That's an amazing company, really amazing. And he told me, Valeri, our board made a decision. We are moving to Agile. Oh, I said, it's very interesting. Okay, I understand how you can use Agile methodology to work on the software. So you create something, you use Scrum, you do sprints, you create, you look back, you create backlog, and so forth and so forth. But how do you do it with a car? Is it easy to change a car? What is a minimal viable car? You see, that's like, yeah, you need to have a ton of steel, actually, to do something minimal viable, right? And replacing and melting this steel back is not an easy process, right? One thing is to just write a code or either remove it and put another code. But what to do with metal? But they're moving there. Then I found a couple of companies which produce medical devices and have been actively, really actively using Scrum for, TRIZ, sorry, Agile. I woke up today at 3 a.m. in Pune and took a flight here, so I'm sorry. They use TRIZ with Agile methodology to actually create new products. And they are customers of mine. They learn TRIZ from me. So I said, wow. But when you want to create something new, what are the best products? If you look at the reasons of startup failures, the main reason, what do you think? What is the main reason of failure of startups, innovative startups, which are trying to come to the world with a new product or new service? Most of people will say, what they will say? Tell me, please. Money. Not enough money, right? The money is over. The time was too short. No. A main reason, 42%, well, it was researched by SBS magazine, 42% fail because they bring a product or a service to the market which is not needed by the market. So the co-founders, startups, investors, they believe that they create something good, something which really adds value, and it will be really demanded by the market, but it's not true. So 42%, it's shocking. If someone asks me what would be a product or a service that win, my first question which will be, what problem is solved by your product or by your service? What product? And that's the main question. So, but to create products that really solve problems are not easy. Because when you want to, even you know what you want to create, even you know that how you want to improve the existing product, you cannot do it. Why? Because it either would require too much resources or you face certain constraints. And this sort of innovative problems emerge at all stages of innovative process, starting from the development of ideas, then trying to implement the ideas, and also at the end, where you actually seem to build a working product, but then you realize that it doesn't work because of some problems that you could not foresee in advance. And a critical issue and a main point for TRIZ is that a major type of problems which exists in innovation are what we call conflicts of demands. Well, a simple example, we have light in that room. How much light should be in the room? First of all, there should be enough light, a lot of light, so we can see each other, we can make records, and so forth. But on the other hand, we want to see the screen very nice. So there should be low light. So there will be a lot of light, and there should be no light. We call this situation conflict of demands, or in other words, we call it contradiction. And contradictions happen everywhere. Well, a typical example, the bicycle. Well, I usually use this example in the Netherlands. You know, Dutch people are fond of bicycles. Well, if you look at the bicycle wheel, there are two types of wheels, the disc wheels and spoke wheels. Why? Why do we need two types of wheels? Because disc wheels, they are used in track for sport purpose. Because they are the fastest, they allow fastest ride. Because there is no turbulence. And the spoke wheel, spokes create high turbulence. That's why spoke wheels, bicycles, riding a bicycle with a spoke wheel is not as fast as with a disc wheel. But another problem with a spoke wheel, with a disc wheel, is that if you go outside and ride it on the street and the weather is bad, the side wind will eventually fly you away together with the bicycle. So, this problem exists for 30 years. Why don't we have yet a solution to this problem? Because you see, that's a contradiction. We want, on one hand, a very cheap and easy to manufacture wheel, but on the other hand, we don't want the side wind to make us flowing in the air. Well, if you go to the coast of the Netherlands, you see how the bicycles really flying when the wind is high. So, nobody solved it yet. So it's difficult because it is contradiction. How do we face such problem? Usually, we create brainstorms. We bring a group of people with different experiences, and we say, okay, guys, now we have 2 hours, let's brainstorm as many ideas as possible. What is the problem with brainstorm? If the problem is easy to solve, brainstorm helps. If a problem requires more sophisticated thinking, and actually the major obstacle why we can't solve really inventive problems is not lack of knowledge. It is what we call mental inertia. We are not looking in the right direction. We are looking in a very, very wrong direction. No matter how many, if the problem is difficult, no matter how many trials and errors we will do, the brainstorm will not help. So that's an idea. that Industrial Research Institute in Washington, D.C. estimated that just create one successful project, we need to generate 5,000 raw ideas. And Buzalian analysis, 75% of companies do not have an effective integrated idea generation and idea conversion process. So to generate ideas is not enough, you have to implement it. So that's the price. As a price we pay, we live in the 21st century. We have excellent technologies. We have nanotechnologies. We have medical technologies. We fly to the moon and even to Mars soon perhaps. But we still, when we try to invent, and invent not just something absurd, but invent on demand, we use the thousands years old methods of trials and errors. No science here. So can we afford to waste so much time and resources? And is there any solution to a problem? Well, definitely yes. That's why I'm here. So what is TRIZ and how it helps? Have you ever heard about TRIZ? Anyone, please raise your hand who heard about TRIZ. Yes, definitely. No, you see, the situation is horrible. Because actually, TRIZ has been a secret of success of Samsung. Samsung is a company I love because it's also a customer of mine. We spend a lot of time with Samsung. Samsung, yeah, you can find this article in Forbes magazine. It's available on the internet. So what makes Samsung such an innovative company? And you will see here TRIZ. Well, there is a reference. I guess you will have access to this presentation, so you can click and watch, or otherwise you can search in Google. And every project in Samsung, at Samsung, goes through TRIZ expertise. So TRIZ is always used at the beginning of the project to create or improve the creative ideas. Well, good news about India. I made this picture just yesterday in Pune, where I was participating in the conference which was called TRIZ for X. So we had approximately 120 people. And before that, I also did a 3-day TRIZ for Business and Management, TRIZ for Business Innovation workshop right here in Gurgaon. Sorry, I used to say New Delhi actually, but I hope you forgive me. Right. So we had 120 people. That was very, very good. And before that workshop and after that workshop, there have been master classes on different parts of TRIZ. Well, a few words about history. TRIZ was created by a Russian engineer, or better say Navy patent examiner, Genihal. So basically, he tried to uncover the principles of technical creativity. And rather than studying behavior and studying the psychological aspects of creators and inventors, he looked at the results of their inventions. In fact, he took approximately 400,000 patent descriptions and studied these patents together with his associates for 10 years. As a result, they discovered an amazing fact that basically innovation, the technology in a way evolves according to certain trends. The evolution and development of technical systems and technologies, engineering technologies first of all, is not chaotic, it's not random. There are certain patterns. And finally, they created a discipline which is today called Theory of Inventive Problem Solving, which we call TRIZ, because TRIZ, it's an original Russian abbreviation, which stands for the Теория решения изобретательских задач. So you can learn this term if you like. All right. So these were major TRIZ discoveries. That man-made systems developed by solving problems and challenges. If you look at the best inventions, they always solve some problem. A breakthrough solution results from overcoming a conflict of demands. That's what I already mentioned, contradictions. I will tell about them a few minutes later. Approximately over 99% of innovative solutions use already existing principle. So basically, what is innovation? Innovation is copy and connect. The solution is already out there, but this solution is not for your area. So actually, the best way to solve problems, inventive problems, and inventive problems are featured by these contradictions of demands, conflicts of demands, is to find where a similar contradiction was already solved and transfer the principle to your problem. And these innovative problem-solving patterns are universal across different domains. Later, we found that actually the same patterns and the same thinking principles could be used for business innovation, for social innovation, for innovation in arts, and we are using it now. Innovative development of man-made systems is governed by certain domain-independent trends. We also know these trends today, which makes it possible to me to actually create the right background for creating future products and think scientifically, from a scientific point of view, about long-term forecast. I will show you some trends. Sure. And finally, new innovative solutions can be produced in a systematic way by reusing previous experience. Now let me show you how TRIZ works and what is an approach and how you can use it. Basically, well, again, we are talking, if we want to invent something serious, breakthrough, we should resolve contradictions. Let's see, a mobile phone should be small to be portable and comfortable to carry, and large to be ergonomic. So you see, a contradiction. Something should have two opposite properties, which is impossible. It's, you know, it's a contradiction. A city bus should be as long as possible to carry many passengers as possible, and short to make turns in a narrow city street. So, and finally, if you like coffee and you go hiking to the mountains, you like to have a coffee cup with you, but you don't want to take a big and bulky coffee cup. So what to do? Yes, please. Thank you. In a plane, a little bit dehydration. So, of course, contradictions may not exist, but there are solutions. And what is most important? Well, usually, developers, engineers say, okay, once we have these two opposite demands, let's find a compromise. No way. In TRIZ, we say, invention is not a compromise. Invention is a result of eliminating contradiction, going out of the demands, of conflicting demands. So, no compromise. And that's how we innovate. So rather than trying to find an optimal value of a parameter, we actually split the contradiction of demands. So in the mobile phone, we split the phone, you see, into two parts. When we need it big, we extend it. When we need it small, we put it down. Well, today, the major contradiction of the phones that you need to have a screen and buttons, physical buttons, was resolved by creating actually buttons on the screen. Contradiction with a bus. Well, make it a double-decker bus. Or make a bus with a joint. Split it to several parts. The same with coffee cup. Well, this is a telescopic coffee cup. It's big when you use the cup, and it's small when you carry it. You know, the telescopic one which you can extend and compress. Now, how to come up with such ideas? Not easy. So that would be a solution to our bicycle problem, right? Rather than finding these compromises and looking for these compromising solutions, we get the solution like that. We decouple the conflicting demands. So, but, well, you see it's actually not easy to produce these solutions. How to, you already said that in all this, actually, you could see that in all these solutions which I showed you, there was something similar. That I split. This phone was split into parts. There, the bus split into parts. there the cup is split in a number of parts. Yeah? And so totally different objects, but the principle is the same. So the power of TRIZ has been that TRIZ identified these principles. And TRIZ made it possible to access these principles in a systematic way. What is inventive principle? Inventive principle is a strategy or a problem-solving direction based on generalization of past experience, showing how contradictions were, or the same type of contradictions, were eliminated by inventors in the past. And this is an example of such a principle. You see, of course, I will not get into details now, but just an example. So, principles of segmentation. It says, well, if you have a conflict over certain demands, then you should do the following. You should design a monolithic object to 2 or more independent or connected parts. You need to compose an object from 2 or more parts to take some parts that can be easily taken away and brought back when necessary. You can even more segment your object if it's already segmented. You can compose an object from a number of smaller objects, granule, powder, gel, liquid, or gas. And the same with a process. If you have a process, you can split the process to a bigger number of activities or bigger number of processes. On the right hand, you see the examples, and I also put some examples here on this screen. You see? Okay, thank you very much. So, what do you have here? Well, the foldable ruler. The foldable ruler is a great thing. That's a ruler which has to be long when you measure something. But when you carry it, it has to be short. So it's split into parts. When you carry it, it's short. When you measure, it's long. A good example was a T-clipper. When the sailors invented a sail, it was a great breakthrough and I would say disruptive innovation for riding on the sea. A sail captures wind. So how much wind you want to capture? A lot. But the more wind you want to capture, the bigger a sail should be, right? So, but the bigger sail is very difficult to control. So the ingenious solution was to split one big sail into a number of small sails. So now you have many sails, and, but you still capture a lot of wind. But each small sail is easy to control. This is something that you digital people know, Windows interface, which was created by Xerox in Palo Alto, Xerox Labs. And then 2 other guys used it to do interface. So you have your computer screen to be big, and at the same time, well, only a certain amount of information you can place on the screen. Split it into windows. That's how Windows interface was created. I'm also doing a lot of training today. And if I remember, I train TRIZ, I teach TRIZ to students at university, also teach professionals in TRIZ. And I remember how it was 25 years ago. We were just going like through a flow with a certain subject. Today, everything is put into short, small modules. So this is a modular training. So you see, it's also segmentation. Well, you see segmentation in art. You see segmentation, well, if you look at the conveyor belt at the airport, it's segmentation. But how do we get access to this principle? There are today 40 such principles. And each principle consists of sub-principles. So it's difficult to find what you need. Some tool was created which is called contradiction matrix, where actually here you have parameters of your contradiction. So parameters which conflict with each other. Today we have such contradiction matrices made for technology, engineering system, for business systems, and we also have a software matrix. Also, TRIZ used in software not as, let's say, popular as in technology or in business. There is still some. So basically, you just identify parameters which contradict to each other, and then in each cell you have numbers of inventive principles. Then you see that from 3 to 4 to 5 principles. Then once you have your contradiction, you read these principles and apply them to your problem, to your contradiction, with an idea that you want to achieve win-win. For instance, if we have light in this room, we want to have a lot of light to see each other. But at the same time, we don't want to see any light, so we can beautifully see screen. How to solve this? How to decouple these conflicting demands? I give you an idea. One of the principles is that you can solve your contradiction in time. Separate conflicting demands in time. Can you do that? Definitely yes. Let's imagine then when I'm talking, you just look at me. When I'm asking questions or or propose some discussions, you look at each other. Make the light. Make the light on. When you watch the screen, make the light off. So that would be solving contradiction in time. Another way, another principle would be solving contradiction in space. How can you solve it in space? No light here in this part of the room, but you have spotlights, right? So that would be solving contradiction in space. Today in TRIZ, we have not only principles which help you to find solutions, but also we have tools which help you to formulate and analyze problems. This is one of the tools called RC+, a tool which helps you to analyze given situation and extract contradictions which create the situation. For example, well, this you don't see it, but if you have the presentation later, you can look at it. This is finding contradictions in the problem, potential losses from stealing digital content. So, but again, we have no time today. I only give you an overview. Another important part of TRIZ is that we know, like I already mentioned, that systems evolve according to certain lines, according to steps, according to patterns. One of such patterns is evolution of dynamics of a system. So let's say material system tends to become more dynamic, actually more agile. That's why we have agile as a replacement to a traditional product development approach, because it's more adapting. So we have the non-segmented object, system of two connected segments, system of segments with flexible link, until we get to the flexible object. And finally, the object is replaced by a field. Well, being in 1999 at Nokia, I showed them this slide. Not exactly this, of course. In 1999, I had most drawings that the pictures were, the ideas were exactly the same. I showed them the evolution of their mobile phone. But you know, Nokia was a special company. They believed that they know things better than TRIZ. No, the history showed us that it wasn't true. So, well, the same is lines also exist for businesses. That's evolution for services. Well, again, I'm not going to explain things now, but because only just to show you, you can find it. Like I mentioned first, there are more than 50. Actually, I compiled a collection of TRIZ books in English. There are 84 books, quite a lot to choose from. Yes. Today we have 35 tools in TRIZ. It's a lot. But not all tools would probably be interested for Agile or to create some kind of combination of Agile. Okay, I will just say a few words. Yeah, there are actually multi-billion products created with TRIZ. This shows how brand value of Samsung Corporation has grown after introducing TRIZ. This has grown the same how this was with Hyundai Motors. Do you think why they are successful? Because of TRIZ. So if we list key benefits from TRIZ, we can say that, first of all, TRIZ helps us having access to this knowledge, which helps us systematically to formulate problems, discover problems, extract contradictions, and solve the contradictions, provides us both with systematic access and knowledge-based access. it drastically accelerated innovation on demand. The good thing also that since it's based on statistical information, the principles which TRIZ proposes actually give us access to best solutions with a maximum ratio benefits or value costs. TRIZ helps to develop right ideas of new products based on understanding of system development patterns and lines. It helps us to apply structured approach to develop innovative ideas. By using TRIZ, a team or teams use shared common innovative language. And finally, well, once you use TRIZ, you develop your personal solving innovative skills. You learn how to deal with uncertain, with tough problems, which require creative solutions in a systematic way. And last few slides I want to show you, that has been an idea how TRIZ can be used in combination with Agile. Also, I said that Agile has actually brought an approach which is in TRIZ, was predicted by TRIZ, that process, any process tends to move from static to dynamic. And dynamics, growth of dynamics means better adjustment to a super system in which your system exists. So that's not surprise that Agile emerged. So this is an idea proposed by some TRIZ researchers and also Agile, where we have this innovative Agile development product. They call it Agile TRIZ framework, where you have a number of iterations. So you use TRIZ at different steps, like at the first step when you discover new ideas. Use TRIZ tools for generating ideas. On a concept development, we develop concept integrating development ideas. When we develop prototype, we implement the concept as prototypes. And finally, when we review the prototypes, we also use TRIZ to identify if we were moved the right way or a wrong way, in addition to other criteria. Well, the same approach can be used for parallel developments of systems that we bring later to a super system. So from my point of view, if we manage, we are in the very, very beginning of bringing together Agile and TRIZ, but there is a big potential. And if we imagine to do that, then we might have the following. Very rapid acceleration of development of innovative concepts. Acceleration of a problem analysis process. Rapid development of a first prototype. Rapid solving of emergent problems. And finally, enhanced evaluation of results. Because one of the biggest problems in the innovation has been probably not really creating a winning idea, but implementing it. Because to implement a big idea, you have to solve many other problems, sub-problems, which are also inventive. That usually makes it somewhere people just stop in the middle of that process. And perhaps, well, I'm sure that using Agile methodology to the product development, innovative product development, together with TRIZ, might really solve this problem. So that was my idea, which I wanted to share today with you. Thank you very much. Questions?
We do have about 5 to 10 minutes of questions.
Yes, please. If you want to book, you see www.x-triz.com. It's my website. If you go to this website, there will be top publications. If you click on it, you will see the list of recommended books. There are 12 books. Yes, they are in order. Yes. But again, well, if you want to really understand the philosophy of TRIZ, there is a book of Henry Altshuler, which is called Algorithm of Innovation. You can buy it at Amazon.com. If you want to know the modern TRIZ, there is a book which is called, published by the company from UK, Oxford Creativity. It is called TRIZ for Engineers, by Karen Gott and Ellen Gott, Karen Gott actually. So these books show the modern state of art. But these books all are about technical use of TRIZ. We also use TRIZ for business problems and business management. These books are not yet available, but they will come. But again, there are these two books I recommend. You can find it on my website. Henry Altshuler, innovation, algorithm of innovation, and Karen Gatt, TRIZ for engineers. Other questions, please? I know that this topic is somewhat new for you, but who knows? Sorry, say once. May I use?
Yeah, thank you. How commonly are we using TRIZ in the market right now?
You can think about big problems, big companies. I'm talking about General Electric. Unfortunately, at this moment, they experience some other problems. But if you think about Samsung, Hyundai Motors, Intel Corporation, Procter & Gamble, Philips, they all are using TRIZ in their R&D. They just don't expose it. Why do you know to let your competitor know? It's your secret weapon. But some companies like Samsung, Hyundai, Intel already show, and I showed you this. So they really do.
Great.
But what is good also about TRIZ, that it can be used by SMEs as well. I mean, small and medium enterprises. Well, because today I only told you maybe 5% about TRIZ. Yeah. Because TRIZ also helps to solve problems with the minimum resources. Okay. So that's good for small companies as well.
Thank you.
So achieving big goals with few resources.
Thank you.
Just a second. Just a second.
Do we have adaptability of TRIZ in aircraft engines, Boeing, Airbus, GE?
Do you have activities at GE India?
No.
Adaptability of TRIZ in aircraft engine manufacturing.
Oh, yeah. Boeing, Airbus, yeah. They are using, and actually Rolls-Royce was one of the first adapters of TRIZ in UK for engines.
What about Pratt and Whitney?
I won't be lying, I don't know. There were several articles by Pratt and Whitney and TRIZ, but I don't really know. Okay. I'm sorry.
Yeah, thank you.
Okay, welcome. But Rolls-Royce was one of the sponsors of TRIZ development in UK. Other questions, please? Using TRIZ, well, software today, well, yes, there is a big company which is called EPAM, epam.com, you can check it. They actually established a whole division of TRIZ in their company, and they develop, but it's mostly business application of software. For instance, recently they managed to cut costs for production of performance. No, I will not tell you exactly because maybe I'm not, I do not, sorry. They actually cut $15 million process from the process development with TRIZ, because with TRIZ you can also do radical cost cutting with innovation. $15 million was saved on the process. But I must say that TRIZ for software is not really works very well. Because what is software? Software is not very innovative product. What is important about software, what is innovative, is to create an idea for a new product, create specifications. That's what's interesting. Also, user experience. That's what mostly TRIZ people who work in software, they work on user interfaces, on user experience, on architectures, and so forth, but not on the coding. There is, I'm sorry to say, not too much innovative in coding. But again, there is a book of Darrell Mann you can find on my website. It's called TRIZ for Software Innovation. It's available at his website.
Thank you, Valeri.
All is available at my website, xtriz.com, goes there. And also there is a list of TRIZ books in English. You will find also one book from Indian engineer who wrote how to use TRIZ for killing viruses, computing viruses. His name is Umakant Mishra, if my memory doesn't fail me. His book also is on the list. But I have two lists, one list of recommended books and another full list of English books. So you will see Umakant Mishra, so you know he's from India. He wrote 2 books on TRIZ for software.
Thank you, Valeri. It will be wonderful to continue Q&A during the networking break, which we have right after.
Yes,
thank you so much, Valeri, for sharing your insights. May I request Prachi Saraf from Guavas to please present Valeri with our memento.
Oh, fantastic. Thank you very much. Thank you. This way. This better. Okay, thank you very much. Thank you very much.